Hello everyone, welcome to Gurudev live NEET classes. Okay, we are here to again to discuss the 10th mock paper. Okay, so we'll just start with the first question here. So look at, so there are, okay, so it's a very simple question. So look at this. When a body is taken from equator to pole, okay, a body is taken from equator to pole, so then its weight, so what happens to its particular weight? So what we know here is, so first we should remember what is the equation for the weight. So weight is given by, so that is a gravitational force acting on the body, okay, and that is given by m into the g, and the g is the acceleration due to gravity, that is maximum at the pole and minimum at the equator, and as a result, and if we are moving from where to where, we are moving from, that is equator to the pole, so weight increases. So that is option 2 is the right answer, correct. Next, so we have a, okay, current I is carried in a wire of length L if the wire is turned into a circular coil. So we have a, okay, length L, so that carries a current I, okay, and this particular one is, so we are making this a circular coil, then maximum magnitude of torque in a given magnetic field B. So if this particular one, okay, it is placed in the region of magnetic field, if this particular one actually is what is called this as, so that is the magnetic dipole. If a magnetic dipole is placed in a region of magnetic field, it experiences a torque, so that is given by m cross b. Now we are looking for a maximum torque, so that is given by just the m into the b. So what is the equation for a magnetic dipole moment? So magnetic dipole moment, we write it as, it is a I multiplied by, okay, so I into area, so here it is circular, so therefore it is a pi r square, okay, multiplied by the magnetic field B. So here we have to write this particular one r in terms of the length L. So because, so this is the total length L, and so that implies what? So that is the circumference is equals to the circumference, that is 2 pi r, okay, that is equals to the length L, and as a result, so what is the equation for the radius? It becomes the, okay, that is L divided by the 2 pi, and just substitute this particular one in this particular equation. As a result, so what do you get the torque then? So that is I multiplied by the pi multiplied by r square, that is L square divided by the 4 pi square, okay, multiplied by the b. So 1 pi will get cancelled, so we are left with L square IB divided by the, okay, 4 pi, okay, that is there in the option 3. So that is actually the right answer. Okay, fine. Next, a stone falls from a balloon that is descending. Descending means what? Descending means it's moving in a downward direction at a uniform velocity of 12 meter per second. And whenever it is released, okay, from that particular balloon, what is its initial velocity? Initial velocity of the balloon, okay, initial velocity of the stone, that is equal to the velocity of the balloon. So that is just the, okay, 12 meter per second, and the displacement of the stone from the point of release after 10 seconds. So in that case, what, okay, so what actually we have to use? So that is the S equals to, okay, ut plus half a t square. So here, okay, it is accelerating in a downward direction, okay, as a result, okay, so displacement of the stone from the point of release after 10 seconds. So as soon as it is released, so there is acceleration due to gravity that is acting on that, okay, and the motion is in a downward direction. As a result, so what we can write? So u is 12 into 10, so that will be 120, okay, plus, so they have mentioned that we have to use 9.8, so for that reason, so we just write 9.8 divided by 2 is 4.9, okay, multiplied by t square, so 10 into 10, that will be 100, so therefore this will be 490 plus 120, so that will be 610, okay, meters. So that is the total, okay, displacement. So therefore option 3 is the right answer for this particular one. Okay, next, a thermodynamic system is taken from a state P1 V1 to P2 V2 by two different processes. Okay, the quantity which will remain the same. So we know that, okay, whenever you are moving from a one point to the other point, let us say it is a, okay, state 1 to the state 2, and if we are moving in a two different paths, okay, what is that going to be the same? Okay, that is the change in the internal energy, so that is going to be the same. And if that is the case, so what we can write? So we, from the, okay, first law of thermodynamics, what we can write? Delta Q equals to delta U plus delta W, Okay, so what is going to be the same? So that is delta U is the same for both the cases. So therefore what we can write, so delta U equals to, okay, delta Q minus the, okay, delta W. So that is the option 4 is the right answer for this particular one. Okay, next, okay, in a hydrogen atom, if the difference in the energy of the electron in n equals to 2 to n equals to 3 is E, okay, then ionization energy of the, okay, hydrogen atom is, okay, what is the equation for the ionization energy? So we know that what is the, okay, what is the value of the ionization energy? Okay, so that is if electron is in a ground state, okay, this is n equals to 1. Okay, if it is in a ground state, whatever the energy, so we have, so we know that E1 equals to what, minus 13.6 electron volt. So what's the meaning of ionization? So we have to make that particular electron free. So that means what, we have to give plus 13.6 electron volt, so that it's, okay, its energy becomes 0. Okay, so therefore, so minus of the E1, so that becomes the, okay, ionization energy here. So first we'll try to write an equation for this. So that is the difference. What is the okay, what is the difference in energy here? So this one we can take it as, so that is E2 minus the, okay, E3, or, okay, if that is the case. Okay, what is the difference? So we have to just try to look at. So we know that energy in a given orbit, we write it as E1 divided by n square. Okay, so energy in the nth orbit. So therefore what we can write here, E1 is a common, so that is 1 divided by 4 minus 1 divided by the 9, and if you simplify this, what do you get? So that is E1 multiplied by, okay, that is 5 divided by 36. So what is E1? We know it. So E1 we know it. Okay, that is energy, that is 13.6, and ionization energy also has the same value, that is 13.6, but it is just the positive quantity, and as a result, so if delta E, what is given? So delta E is equals to the E. So now we take this delta E as E, and as a result, so what is that ionization energy? That is the E1 itself. So therefore it is 36 divided by 5 multiplied by the E. So we can take this as the 7.2 multiplied by the E. So that will be the right answer. So that is the option number 2. Okay, okay, dear students. Okay, fine. So next, if the amplitude ratio of the two sources producing the interference pattern is, okay, 3:5, then the ratio of intensity at maxima and minima. So what happens in the case of the maxima? We know that, so, okay, in the case of the maxima, okay, both the amplitudes, okay, they are in a coherent, okay, they are coherent, and as a result, so what happens? So the amplitude, okay, amplitude in the maximum situation, what we observe, so that is the A1 plus A2. But in the case of the minimum, what we observe, the amplitude becomes what? A1 minus the A2. Okay, if you just do that, okay, for a maximum, what we get, if you just remain the, okay, take that particular ratio itself, so then it will be 8, and the difference will be just the 2. And intensity is as, so ratio of the intensities of maxima and minima. So that is, we generally we write what, okay, intensity is directly proportional to the square of the amplitude, and as a result, so we know the I max, okay, we have to find I max divided by I minimum, so that is equal to what? A max square divided by A minimum square. Yeah, okay, A max square will be what? So that is 64. Okay, A minimum square, so that will be, okay, 4. So therefore what we can write, it is just 16:1. So therefore, okay, option 2 will be the right answer, right? Fine. Next, so, okay, 220 volt, 50 hertz AC applied to a resistor. Okay, then instantaneous value of the voltage. So when you write the instantaneous value, how do you write? So that is a V0, okay, sine omega t. So what is the meaning of V0 here? V0 is the amplitude of that particular equation. So whenever they give this particular value, what is the meaning there? So that is the VRMS. So what is the relation between the VRMS and the V0? VRMS is V0 divided by the root 2, and as a result, so what I can write? So 220 multiplied by root 2, that becomes the V0, okay, multiplied by sine omega t. What is omega here? 2 pi into f. F is how much they are given? So f is 50. 50 into 2 pi, so that I can write as it is 100 pi, so multiplied by the t, so that will be the right answer. So here that is the given by the option 1. Okay, so fine. Next, so given below are the two statements. Look at the first statement. A charge is moving in a uniform magnetic field. Okay, charge may experience no magnetic force. So we know the equation for the magnetic, okay, force. What is the equation for a magnetic force given by? So that is Q times the, okay, V cross B. Okay, that we take it as the magnetic force. So whenever this cross product becomes 0, so then the force also becomes a 0. So cross product can become 0 only when theta equals to 0 degree or it equals to the 180 degree, and as a result, so what we can say, it can become 0, so that is a correct statement. And next one is what? Kinetic energy of a charged particle moving in a uniform magnetic field may change. So is this possible? So as a consequence of this, what we have discussed, what we have discussed in theory is, so work done by this particular magnetic force is always 0, and using the work energy theorem, what we can say, so delta K equals to the delta W, so that is always equals 0, so it cannot change, so therefore this will be a wrong statement. Only the first statement is correct, so therefore first option is the right answer. Okay, so next one. So look at, there is a given circuit here. Using this, so we have to look at, it represent which type of a logic gate. Okay, so if that is the case, now we can just look at, try to understand this particular situation what we have. If we have something like this, so this is the 0th state, this is the 1. So that means what? Whenever it is open, no signal is passed. In that particular case, we take it as 0. And if it is closed, signal is passed, or we have a current. In that particular case, we take it as 1. And if you just look at this particular situation, so if it is if one of them is closed, if one of them is closed, so then also the whole part is just an open system. And again what happens, there is no current passing through this, and as a result it will be moving, current will be moving in a downward direction. Current will be moving in a downward direction. As a result, LED glows. When we observe this particular one, whenever for a 0, 0, that is 1, 0, 0, 1, for all the three cases, this particular one is always open, and as a consequence, LED glows. So that means whenever the inputs are in this particular fashion, we have the output. If both are closed, means we can take it as 1, 1. So in that particular case, what happens? Current will be passing through this because it is a short circuited, and as a result, current will not pass through this, and LED does not glow. And as a result, what we can take? So this is a 0. So 1, 1, 1, 0. So that is the result for what? So that is for a case of the NAND gate. So therefore, it is the second one is the right answer. Fine. Next. For a hydrogen gas, Cp minus Cv equals to A, and for oxygen gas, Cp minus Cv is equals to B, then the relation between A and B is what? And so always just look at this in the bracket, whatever is given, so that is very, very important. So what that is, they have mentioned that it is a specific heat capacity. So but if it is a molar specific heat capacity, so what we observe, so Cp minus Cv is always equals to the capital R, that is a constant that does not change. So if it is a what? If it is a molar specific heat capacity, that becomes the same, A equals to B, that will be the right answer. But here what is given? So that is not molar specific heat capacity, but is actually a specific heat capacity. In that particular case, what is the equation? So we know that, so that is Cp minus Cv, so that is equals to capital R divided by the capital M, where M is what? Where M is the molar mass of that particular gas used. So what is the molar mass of the hydrogen? We know that, molar mass of the hydrogen here, hydrogen gas, that is H2, so that we can take it as a 2 gram. In the same way, molar mass of the oxygen, we can take it as that is O2, so therefore it is 32 gram. And as a result, so what we can write here, so this will be R by 2. For a first one, for hydrogen, I'll just write it as hydrogen. This will be A equals to what? So A equals to R by 2. In the same way, B equals to what? That is R divided by 32. And if that is the case, what is the relation between them? So we can write this as A is R by 2 and B is R by 32. So therefore, what we can write? So you can just look at this. So R, I can rewrite it as R divided by 2 into 16. So what is R by 2? R by 2 is A. So this one, so we can write it as it is A divided by 16. So therefore, A equals to what? 16 times the B. That is the option A is the right answer. Correct. So here we should understand this particular one. Molar specific heat capacity and also it is a specific heat capacity. What is the difference? If you know that, then it is a very simple numerical. Correct. Next. Electric field due to an electric dipole at a distance r okay, from its center in an axial position is E. Okay, if the dipole is rotated, okay, through the angle of 90 degree about its perpendicular axis, so then magnitude of electric field at the same point will be, okay, something like this. So here let us say here we have a dipole and this is the axis and here is the point P. Okay, what they have given, so first at this particular point electric field is E along the axis. Next, if the dipole is rotated through an angle of 90 degree about its perpendicular axis, this is the axis, perpendicular axis is this particular one. If you rotate this way by 90 degree, so then it is in this particular plane, okay, and this particular point is in an equatorial line. And what is electric field, okay, at that particular point? So okay, this is okay, electric field along the axis. Now we have to look at for whenever you rotate that, okay, what happens? So that point P is along the equatorial line. As a result, so what is the EE? So that we write it as, so it is actually, it is the half of the, okay, electric field along the axis. So straight away, okay, we can take it as option 3 is the right answer here. Okay, so next one. So next one is based on the dimensions. Okay, first chapter, okay, the dimensions of A by B in the given equation where P is the, okay, that is what, okay, pressure. So now we'll just concentrate at the numerator. So what we have here, A minus T square. So whenever you are adding or subtracting, so what we know, dimensions must be the same. So dimension of the A must be D equals to the dimension of the T square. So therefore it is T power 2. And what will be this? Now we have to look at dimension of the B. So how can we write this? Dimension of the B, you can, okay, interchange the terminologies. So therefore here dimension of the A divided by, so dimension of the A, I'll just write it as dimension of the A, so divided by dimension of the P, okay, multiplied by dimension of the X. Okay, what is the dimension of the, okay, A? So that is T power 2. Okay, what is the dimension of the pressure? So that is ml power minus 1 T power minus 2. So that we know it. And displacement or X, that is L. So L power minus 1 plus 1 will get cancelled. And as a result, so what we can write here? So as a result, so what we can write is, so T power 2 we have already here for this, and T power minus 2. So whenever it goes to numerator, okay, it becomes T power 4. So therefore what we can write, so that is the, so B will be having, so that is m power minus 1, okay, T power 4. So that is the dimensional formula for a B. So but what actually is asked is, so not for A and the B, but actually the ratio of A to B. So if it is ratio of A to B, okay, A we know that it is T power 2, okay, and divided by it is m power minus 1 T power, okay, plus 2. So as a result, so what we can write, so this m goes to the numerator, it becomes m, okay. So here what we made, so this is plus 4. So therefore it becomes T power minus 2. So that is the option 2 is the right answer. Okay. Fine. Next. Okay, 3 charges plus Q, okay, plus Q and plus Q placed at the vertices of the equilateral triangle of side L as shown in the figure. If the net electrostatic energy of the system is 0. So whenever we have a 3 charges, what is the equation for the electrostatic energy? So between these two we have a 1 energy term, and between these two we have one energy term, and between plus Q and plus Q also we have a 1 energy term, and as a result the sum is equals to 0. So therefore first we'll write the equation for the total energy and then we'll, okay, equate it to 0. So therefore, so Q into plus Q, capital Q into plus Q, there are two terms. So therefore I straight away I'll write that as, so K into capital Q into Q divided by the length L, because of we have the two terms, so therefore 2, okay, plus, okay, and because of this particular one, so that is a K Q square divided by the L, and that is actually equals to 0. And if that equals to 0, common term we can take it outside and we can neglect that. And so what we can write here, so this implies, okay, that is 2, okay, 2, so 1 Q also we can, okay, multiply that, so that is Q is equals to minus Q, so therefore Q equals to minus Q divided by the 2. So first you have to shift this one to the right hand side, so common terms, okay, will get cancelled, and as a result finally we are left with what? Finally we are left with the minus Q divided by the 2. Okay, so match the following. Okay, so here actually, okay, we should have given the options here, so by mistake, okay, that option is not available here, so we'll just, okay, we just find the dimensions, okay, and we'll move on. So okay, stress into the strain. What is that stress into the strain gives us? so we know that, okay, strain is a dimensionless quantity, okay, stress is force per unit area, and as a result, what is the unit for this particular one becomes, okay, that is stress is what, force per unit area, so that is Newton per meter square. So do we have an option in this particular case, Newton per meter square? We don't have. So for that reason, so what we can do is, so we can, okay, we can simplify according to the, okay, given option here. So I'll just do it as, so okay, I'll just write something like this. I'll multiply by m and m power minus 1. As a result, I'll get Newton meter and, okay, meter to the power minus 3. What is Newton meter? So we can write as it is a joule, so joule per meter cube. So that is, we can straight away take this particular one. Okay, and next one is what? So that is, okay, A goes to this particular one. The next is, okay, y into A into L. So what is y? Y is the, okay, Young's modulus. Young's modulus has the same dimension of the stress, that is, okay, that is force per unit, force per unit area. So we can take it as Newton per meter square and multiplied by area divided by the L. So I can write this as YA divided by the L, so that we can write it as Newton per meter square divided by the L is again, so what is that? It is just the meter. Okay, so therefore these two will get cancelled. So okay, it goes to the Newton per meter, so that is the P. And next is Y into L cube. So what is that Y? Okay, Y into L cube. So we can write it as, so Y is Newton per meter square multiplied by meter cube, so that becomes Newton meter. Okay, Newton meter. So that is what Newton meter means. It is a joule. So therefore, okay, that is the C, and this automatically it goes to the, okay, D. Okay, is this clear? Okay, fine. Next, drift velocity Vd varies with the intensity of the electric field as per the relation. So what is the equation for the drift velocity? We write, so that is, it is actually the average velocity. So therefore we write as EE divided by the m multiplied by the relaxation time. So therefore it is, what we can say, it is directly proportional to the E. So therefore that is the first option is the right answer here. The next, so three blocks of masses m1, m2, m3 are connected by a massless strings as shown on a frictionless, okay, table. So that is very important, and they are pulled with the force of, okay, T3. So this is actually the T3. So T3 is how much? So that is the, okay, 40 Newton. Okay, M1 is, okay, M1. So this is actually the 10 kg. Okay, this M2 is 6. Okay, M3 is 4. So this one is actually, it is T2. So here in between we have T2, and here in between we have the T1. Okay, so then, so what is the T2? So we have to calculate what? T2. So you should remember this way. Okay, T3 is the one force, okay, that is pulling all M1, M2 and M3. And in the same way, what we can say, so T2 will be the force that pulls M1 and also the M2. So therefore, so T2 will be lesser than T3. So but what is the fraction of that particular, so one we can write as T2 equals to, so that is M1 plus M2, okay, divided by M1 plus M2 plus M3, okay, whole multiplied by the, okay, T3. Okay, if that is the case, what is M1 plus M2? 10 plus 6, that is 16. Okay, 16 plus 4, that will be, okay, 20. So multiplied by T3 is how much? So T3 is 40. So therefore it becomes what? So 16 into 2, so that will be 32 Newton. Okay, fine. Next, given below are the two statements. Okay, first one is what? When the wavelength of the incident radiation, okay, in a photoelectric experiment is decreased. If wavelength decreases, what happens to the stopping potential they are given? So stopping potential will also decreases. So but what we have remembered here is, so stopping potential is directly proportional to the frequency. If the wavelength decreases, what happens to the frequency? Frequency actually increases. So therefore stopping potential also increases. So but here they have given that it decreases. So that is a wrong statement. Okay, next one is what? With a decrease in the wavelength, energy of the incident light increases. So what I just told now, if the wavelength decreases, what we know? Frequency increases, and okay, this energy is directly proportional to the, okay, frequency, therefore energy increases. So that is a right statement. So A is false but R is true. So that is a right answer. Next, so multiply two numbers. So if that is the case, okay, express the result with the correct number of significant figures. So here, Okay, so look at, so what is that rule we have to remember? Whenever you are multiplying, okay, you should know the significant figure for both the numbers. So what is the significant for this significant figure? That is a 5, and for this particular one it is just the 3. And if that is the case, so which one is the right answer? But there is a one, okay, small typing error in this particular case. So it is 65.8 multiplied by s. We don't have this particular s, so it is just the 65.8 is the right answer, not the s. Okay, so then potentials of a two plates of a capacitor are plus 10 volt and minus 10 volt. The charge on one of the plate is 40 coulomb. So okay, something like this. So charge is, okay, on one of the coulomb, that is a 40, and here we have a, let us say it is a plus 10, and here we have a, okay, potential of minus 10. So whenever we look at the potential, so here we look at only the potential difference. What is the potential difference here? So difference of these two, that will be 20, and charge we know it, so that is a 40 coulomb. So if that is the case, what is asked here? Capacitance. What is the equation for the capacitance? So capacitance is, so charge divided by the, okay, potential difference, so that is 40 divided by 20, so therefore it is a, okay, 2 farad. So that is the right answer for this. So most probably we will make a mistake while finding this delta V, okay, so that we should be little careful. Next, two different loops are concentric, okay, and lie in the same plane. So first we'll, okay, draw this diagram. So they are concentric, okay, and so they are in the same plane. The current in the outer loop is clockwise. So outer loop is clockwise, okay, and increasing with the time. So this is a function of time, so that increases with the time. The induced current in the inner loop is, so here what happens? So there will be an induction, and as a result, so what it does, so it tries to decrease the magnetic field, and as a result, so it will be in a exactly in opposite direction, so that is the counterclockwise. So that is the option 3 is the right answer. The next, the wavelength of light in a two liquids X and Y, so that is 3500 and 7000 Armstrong respectively. Then the critical angle. So what is the equation for the critical angle? We know that it is a sin IC, that is equals to 1 divided by the n. So first we have to find the refractive index of that particular, okay, denser liquid. So what is the refractive index? So there we get it as, so that is a lambda 2 divided by the lambda 1. So here it becomes 7000 divided by the 3500. So that becomes the 2. Okay, sin I is 1 by 2 as a result. So when it can become 1 by 2, okay, so that is possible only when it is at the 30 degree. So therefore it is option 3 is the right answer. Clear now? Fine. Next, moment of inertia of a body depends upon, so what? One is axis of rotation, torque, angular momentum, angular velocity. So that is a, okay, that depends on the rotation, okay, and that also depends on distribution of the mass about the axis of rotation. Okay, so this one I think I'll just recall a one simple example. So let us say we have a ring, okay, and the axis of rotation is this particular one. Okay, it is perpendicular to the plane passing through the center. So then what do you write? It is mr square. And if the same thing, if the, okay, if the axis is parallel to this, okay, and then what do you write? So we write it as mr square plus mr square. Okay, so therefore it becomes 2 mr square in this case. So therefore moment of inertia value changes according to the change in the axis of rotation. So therefore, okay, first one is actually the right answer. I hope it is very clear. So very simple one, right? Okay, another very, okay, simple question. Look at the Young's modulus of the material of the wire is equal to, what is the definition of the Young's modulus? So how do you write the, okay, this modulus of elasticity, we write it as the ratio of, okay, stress to strain. So that is a general one. So here what we can say here, that is the stress required to produce a unit strain. So then we can say that, okay, that is a Young's modulus. So therefore straight away that is the option 2 will be the right answer for this one. Okay, next, a sphere is released on a smooth inclined plane from the top. Okay, when it moves down, so okay, something like this. So we have a smooth inclined plane and there is a, okay, sphere, so that is under a rotation and it move in a downward direction. So if that is the case, angular momentum is, okay, so now we have to look at what happens to the angular momentum. What is the equation for the angular momentum? The very general equation I am writing. So okay, for any particle which is moving with the some velocity, so then, so we write it as L vector equals to R cross the P. Okay, so where R is the vector, that is a position vector, okay, that is defined from the center of, or okay, the center of the reference frame. Okay, so now we'll just try to look at, and what is the meaning of conservation? Okay, that is, okay, if it is angular momentum is conserved, so what's the meaning? Angular momentum is conserved means, okay, angular momentum is a constant. So angular momentum becomes a constant only when torque acting on the system is 0. So this is very important. If the torque is 0, then L is constant. If torque is not equals to 0, so then it is not a constant. Okay, so then we look at this way. So conserved about every point. So okay, so conserved about any, okay, any point they are saying. So now I will just choose a one particular point. So okay, it is the, okay, the center of mass, which is at the exactly at the center. You can take any other point. Okay, so we can, okay, if you just take this as a point, okay, and as a result, so what happens? So r I can take it as this particular one, r vector. Okay, I am taking this as the point where we are looking for the conservation. And in that particular case, if it is under a rotation, so then it will be having some velocity v, and what's the angle between them? Angle between them will be 90 degree. Okay, so, and hence what we can say, so it is a, so the force is also acting in the opposite direction, because if it is under a rotation this way, okay, in this direction also we have the force. Okay, in the same direction we have the force. R cross F is actually the torque. Okay, right, what is the torque equation? So torque equation is R cross F. So in this direction we have the force. Okay, this is the direction of the R. So R cross F, okay, that is not equals to 0, and therefore, okay, angular momentum cannot be, okay, constant. And if that is the case, option A is wrong. Okay, next, conserved about the point of contact only. So if this is a point of contact, so I have just explained for the same here. Okay, so therefore that is also, okay, not possible. And next one is what? Conserved about any point on a line parallel to the inclined plane and passing through the center of the ball. Okay, something like this. Okay, this is the point, and if you look at any point, okay, if you look at any point, so what happens here? This is the center of mass. Okay, and about this particular point, so what we can take? So this is the R. Okay, and because it is in a, okay, downward direction, so it, okay, because it is moving in the downward direction, so what we can say, mg sin theta, that is acting in the downward direction. Okay, so therefore what happens here? What is the angle between R and the F? So what is the angle between R and the F? Okay, that is 180 degree, and as a result, what is R cross F? R cross F becomes 0. Or if you take this as a point, and again what I can take, so this is the R. Okay, this is the R vector, and again, okay, this is a force vector. They are in the same direction. If they are in the same direction, so what we can say? If they are in the same direction, again the theta becomes, okay, okay, 0 degree, and therefore okay, torque becomes 0, and therefore it is conserved. So that is the option C is the correct statement. Okay, is this one clear? Fine. Next, a uniform chain of length L and mass m is lying on a smooth table. Okay, if it is lying on a smooth table and 1/3 of its length is, okay, hanging vertically down, okay, over the edge of the table, okay, over the edge of the table, then the work required to pull the hanging part on the table is something like this. So here we have a chain. So look at this carefully. This is okay, interesting one. Okay, if that is the case, what is the length they have mentioned here? So this is given by, so that is the 1/3 of its length, so that is L by 3. Okay, and if that is the case, okay, we have to pull this particular chain so that this particular hanging part is on the table. So if this particular one has to be on the table, so we have to perform some work. So what is that particular work? So now for this particular part, because it is okay, so it is an extended body, so what we can take, the center of mass is exactly at the center of this particular one. So if that is the case, what is this particular length? So that is exactly half of this, so therefore L divided by the 6. Okay, L divided by 6 will be this. And what is the work done here? So work done equals to what? Because we are pulling this against the gravitational force, so we can take this as, okay, mgh. So what is that? M, mass of that particular, okay, hanging part of the chain, so that we can take it as m by 3. Okay, m, okay, g, h, what is that? H is, okay, L by 6. So therefore what we can write? So that is mgl, okay, divided by 18 will be the, okay, the work done to bring it onto the table. Yes. Next, escape velocity from a planet is, they have given it as ve if its mass is increases to, okay, 16 times, and radius increases to 4 times. So what is the general equation for the VE? We'll just try to recall. So that is 2gm divided by the r. Okay, so where r is the radius, m is the mass of that particular planet. Okay, then the new escape velocity will be what? So if the m becomes what? M increases to 16 times, r increases to 4 times. So therefore effectively VE changes to root of 16 divided by the 4 times the previous one. What is the 16 divided by 4? 16 by 4 is a 4. So root of 4 is what? So root of 4 is a 2. So therefore velocity increases by 2 times. Correct. So we are just using this particular one, and the constant we are neglecting it, only the one which is undergoing a change. So based on that, so we have given that particular answer. Okay. So right, next one. The horizontal range of a projectile is 4 root 3 times of its maximum height. So what is the equation for this? So whenever we have something like this, so we know that tan theta, that is equals to 4h divided by the r. Okay, so what is the r they have given? R is 4 root 3 times the maximum height. So that is 4 into h divided by 4 root 3 multiplied by the h. 4 h will get cancelled, and as a result tan theta is 1 by root 3. So we know that. What is the theta then? So theta is 30 degree. Very simple. Next, a particle starts with a velocity 2 meter per second and moves in a straight line with a retardation, with a retardation of 0.1 meter per second square. The first time at which the particle is 15 meter from the starting point. So it is a retardation. Initial velocity is given. So displacement is s equals to ut minus half at square, because it is undergoing retardation. So s equals to what? 15. So u is 2. Time is how much? Time they have not given, so we have to find the time. So that is half. Acceleration is what? Acceleration is 0.1 multiplied by the t square. So we'll simplify this. If you simplify this, what we get? So therefore, so first will so that is 0.1, I take it as 1 by 10. So 1 by 10 means what? 1 by 10 into 1 by 2 will be 1 by 20. So this will comes 1 by 20. So if that is 1 by 20, multiply the whole equation by 20. If you multiply the whole equation by 20, 20 into 15 will be 300. That is equals to, multiply the whole equation by 20. So therefore it is a 400t minus t square. Or if you simplify further, it is a t square minus 400t plus 300, that is equals to 0. So what is the equation for the time then? So that is by simplify the quadratic equation. So therefore it is a minus b, that is a 400 plus or minus b square, so that is 600 minus 4ac. What is that? 4 into a into c. A is the coefficient of t square, c is the 300. So 4 into 300 will be 1200 whole divided by the 2a. So 2a is just the 2. So therefore what we can write? 400 divided by 2. So that I write it as it is a 200 plus or minus. So what will be this particular one? So it is so here we get it as it is a 1600 minus 200. So it implies that it will be just the 400. So therefore divided by the 2. So it is, we write as it is a 200 plus or wait a minute. So we'll make we have done a one simple big mistake. So that is 400 square. So I can take this as, so 400 square means 10 power 4 it will be. So therefore I'll just write rewrite this particular part, only this particular part. So look at this. So 10 power 4 will be a common. So I'll just write it outside. So square root of the 10 power 4. So I just take it as 10 power 2. So then I can simplify this. So that is 16 minus 4 into 3, that is just the 12. Only this particular part. So then what do you get here actually? So that is 16 minus 12 will be just the 4. 4 into 10 power 2. So if that is the case, what do you get? Root 4 is 2 by 2. So that will be that is 200 plus or minus again. So we get it as so here we get it as 2, that is 100. So here actually we are looking for 20 by, so there is a, okay, one simple mistake we have done here actually in the beginning itself. So what we have done, how we have got this particular equation? By multiplying by 20, right? So whenever you multiply this, so 20 into 15 will be 300, that is correct. So 20 into 2, so 20 into 2 will be just the 40. So we have to write it as, okay, 40 here, students. So we have to look at this. So that is 40 into the t, and here we have got, so that is a 300. So that is correct. And as a result, okay, so if you just simplify accordingly, okay, if you simplify accordingly, so I'll do it. So look at this. So minus 40, so that is the, okay, plus 40 plus or minus, so that is 1600. So minus the, okay, so it is minus the 1200, okay, divided by the 2, and as a result, so that will be, okay, 20 plus or minus, okay, that is the 10. So therefore we get 30 or 10 seconds. So therefore, so that is the first one. So they are asking starting, okay, so what is the first time at which it becomes, okay, 15 meters. So therefore what we have to take, so we have to take, that is the 10 seconds. Okay, is this clear? So we have done a one simple mistake, so we have rectified that. Okay, fine. Next, velocity at a mean position of a particle executing simple harmonic motion is v. Okay, velocity of the particle at a distance equal to the half of the amplitude. So what is the general equation for the velocity? We know that. So it is omega, okay, root of a square minus the y square. What is the y here they have given? So y is half of the amplitude. So that is y equals to what? So y equals to a divided by the 2. So if that is the case, so if you, okay, simplify here, y equals to what? A by 2 whole square. If it is a by 2 whole square, so then it is a square, okay, minus, okay, a square divided by the 4. Okay, therefore what I can take a square, I can take it as a common, omega multiplied by the a. Then 1 minus 1 by 4 under the square root. So therefore it is a root 3 divided by the 2. So what is this particular one? We can take that. So omega into the a, that is the maximum velocity. So v equals to v naught, okay, root 3 divided by 2. So that will be the, okay, that will be the right answer. So that is option 3 is the right answer here. Okay, so next, two vessels A and B having equal volume. So that is volume of the one equals to the volume of the two. Okay, has the same, okay, equal masses of hydrogen in A and helium in a B. So at temperature is also fixed. Okay, then which one is the right statement? So they have given what? So mass of A, okay, that is equals to the mass of the B. Okay, mass of A contains what? A contains the hydrogen and B contains the helium, and we have the same volume, so mass is also the same, they are saying, if that is the case. So we know that what is the molar mass of hydrogen? Molar mass of hydrogen is just the 2 and molar mass of the helium is the 4. Okay, if the volume is the same and mass is also going to be the same, so number density will be different. So if the mass has to be the same, okay, if the mass has to be the same, so number density of hydrogen, so must be twice the number density of the helium, because now, okay, mass of the helium is what? Molar mass, that is 4 gram, okay, and molar mass of hydrogen is what? That is 2 gram. So that means mass has to become same, means number density of the hydrogen must be double that of the helium. So that is the condition. Okay, so now we'll look at all the statements. The pressure exerted by the hydrogen is half of that of the exerted by the helium. So now what we'll do is, what is the equation for the pressure? 1 by 3 Nm V square average. Okay, and we also know that V square average and also the, okay, RMS value, okay, this particular one V square average is directly proportional to the absolute temperature. They have given that mass is the same and they have given that temperature is the same. The temperature is the same, okay, whatever may be the, okay, molar mass, okay, so that is what, okay, the average velocity, that will be the same. If that is the case, okay, if that is the case, so what we can say here, okay, what we can say, P is directly proportional to what? So P is directly proportional to the N. If the P is directly proportional to the N, what we can say here? So okay, hydrogen will be having a pressure that is twice that of the helium. So look at that, if you have any option here. So pressure exerted by the hydrogen is, okay, look at this last, twice that of the helium. So that is the fourth one will be the right answer in this particular case. Where two equal drops of water are falling through air with a steady velocity v. Okay, so I'll just write something like this. So here we have a mass m moving with the steady velocity, okay, and here we have another mass m moving with the steady velocity v. Okay, if the drops collides, okay, then the new velocity will be, so mass becomes what, okay, 2m. Okay, if they combine in this particular fashion, so what happens to the new radius? Let us say this is the old radius a, okay, sorry, r. Okay, what will be the new radius in this particular case? So in the, okay, in this particular one we know the general equation, that is, okay, n to the power 1 by 3 multiplied by the r. So n is what? N is number of, okay, small drops, okay, which is undergoing combination. So in that particular case, so we can, okay, we can write as 2 power 1 by 3 multiplied by r will be the new radius. If that is the case, so terminal velocity, what they have given here is the terminal velocity. So terminal velocity is directly proportional to what? So directly proportional to the square of the radius of that particular one. If the terminal velocity is directly proportional to the square of the radius, okay, I'll just write as square of the radius. So therefore what we can take, so it is directly proportional to, so that is 2 to the power, okay, 2 by 3 multiplied by r square. So therefore I can write as, so new terminal velocity equals to 2 power 2 by 3 multiplied by the v. Okay, so that will be the third one will be the right answer. Okay, next, Young's double slit experiment, the fringe width will remain the same. If the fringe width remains the same, so what we can say here? Okay, so what is the equation for the fringe width? So that is lambda d divided by the d. Okay, so when can it becomes the same? So look at this. So if lambda and d are doubled, so lambda is doubled, capital D is also doubled, so okay, fringe width increases by 4 times. So that is not the case. Next, both d and capital D is doubled. So look at this. Capital D, that is in numerator, small d, that is in denominator. If both are doubled, so that will get cancelled each other, and as a result, okay, fringe width remains the same, right? So therefore it is the option 2 is right answer. So we'll go to the next one. Okay, the center of a wheel rolling on a plane surface moves with the speed, okay, that is the v naught. What is that? Okay, v naught is the speed of the center of the wheel. Okay, then particle on the rim of the wheel, okay, particle on the rim of the, okay, I'll just draw this. Okay, this center has a velocity v naught. So particle on the rim of the wheel at the same level. So that means what? Maybe this one or maybe this one. Okay, same level as that of the center will move at what speed? So at this particular point, because it is also under a rotation, as a result, for this particular, okay, particle, okay, velocity is given by this. But as a result, but actually the whole system is under a, okay, okay, with the velocity that is given by the v naught. As a result, so okay, its actual velocity will be in this direction, because it's a v naught and v naught, angle between them is 90 degree. So we can directly write the answer as root 2 times the v naught. Okay, is this one clear? Fine. Next, in the circuit, power dissipation is 150 watt. So then what is the value of the R? So look at this one. So we have a parallel combination. Okay, 15, okay, volt is given across that. Okay, we know the power P. Okay, so therefore what we can write? So we know the V here. So I'll just write it as P equals to what? V square divided by the R effective. It is not just the R. I'll just write it as it is a R effective. Okay, so if that is the case, what is the P here? P is 150, so V is 15 into 15, so I write it as 50, 150, okay, 15 into 15, so this becomes 10, so divided by we have the R effective. So as a result, what is R effective? So R effective will be 15 by 10, so that is write as 3 by 2. So what is R effective? We know for the parallel combination, so that I can write as it is R, okay, 2R divided by R plus 2. Okay, if that is the case, so simplify this. Okay, so when you simplify, okay, when you simplify this, okay, that will be what? So 2 into 2, that will be 4R, okay, that is equals to, okay, that is equals to 6R, okay, plus 6. So wait a minute, so we have done what? R plus 2, R into 2 divided, so wait a minute, so we'll just cross check this particular one. So power equals to what? V square divided by R, so that's correct. Okay, so power is 150 they have given, so V square is 15 into 50 divided by R, so therefore it becomes R effective becomes what? So R effective becomes the, okay, 3 by 2. So in this particular case, Okay, what's the value of the R? It is us. So because they are in a parallel combination, so what we can write? So this particular R effective will be that is 2 into R divided by R plus 2. Okay, and if you just equate this, so that is 3 by 2. Okay, so if it is 3 by 2, okay, so what we can write here? So that is a 4R. Okay, 4R equals to 3R plus 3R plus 6. Okay, in that particular case, shift this, so R becomes equals to 6. Okay, so that is the option 2 is the right answer. So when simplifications we made one simple mistake, we have rectified that. Next, the upper half of an inclined plane of an inclination of theta is perfectly smooth while lower half is rough. Okay, so we'll just try to draw one simple diagram here. Okay, something like this. So we have an inclination theta. So half of that is, I'll just denote this way. So this one is rough. We have a mu. Okay, and this particular one is for this one mu equals to 0. Okay, then block starting from rest at the top of the plane. So that means at this particular point, initial velocity is 0, and at the bottom, if the it comes to rest at the bottom also. So that means whenever it reaches this particular point, its final velocity is also again it is a 0. If the coefficient of friction between the block and the lower half of the plane is given by, so what is the value of the mu? So that we have to find out. So here it has the initial velocity that is 0 and final velocity that is also 0, and as a result, so which particular theorem, so it will be very useful to calculate this. So here there is actually, if you just look at the change in the velocity, there is no change in the velocity, and as a result what we can say, there is no change in the kinetic energy. So here what we can take, so delta K equals to 0. So from work energy theorem what we know, so work done equals to what? So change in the kinetic energy, so that is equals to 0. So but actually here in this particular case there are two forces acting whenever it is moving in a downward direction. So one is what? So whenever we have a block that is moving in a downward direction, so one will be what? That is the gravitational force mg sin theta acting in a downward direction. So in this particular part we will be having, from here to here we will be having mg sin theta that is acting in a downward direction. And next one more is what? Whenever it is a smooth surface, there is no frictional force. But whenever it enters here in this region, so there is a friction, and friction will be what? Friction will be, because it is moving in a downward direction, friction will be in a upward direction. And what is the equation for the kinetic friction here? So that is a mu mg cos theta. And because of this particular force, there is another work done. So therefore what we can say, this total work done is 0. So therefore we can say that work done by the gravitational force plus work done by the frictional force, so that is exactly equals to 0. And that implies what? They are equal and opposite. So therefore I can just substitute. So that is I can just write the magnitude wise. If you write, look at magnitude wise, Wg equals to the Wf. So what is the work done by this particular one? Gravitational force is acting from first point to the last point. So therefore I write it as, so mg sin theta is the force multiplied by the displacement is here. And next one is what? So we have the work done by the kinetic friction. So what is that? So that is a mu mg cos theta, and that is the force acting on the only in this rough region. So therefore what we can say, multiplied with the length. So length actually you have to write as it is half of that. And as a result, if you just look at this, mg will get cancelled here, and then L also will get cancelled. We are left with what? So mg cancelled, L cancelled. Here it is sin theta, here it is mu cos theta by 2. And as a result, if you just move to the left hand side, mu equals to what? Sin theta by cos theta multiplied by the 2. So therefore it is a 2 tan theta. So therefore mu equals to 2 tan theta. So that is the option. So we'll look at into the next question, that is the 36 here. That is, a body of mass m is attached to the lower end of a spring. Upper end is fixed. The spring has a negligible mass. When the mass m is lightly pulled down, then we have the oscillation and the time period is given by 3 seconds. So we write that. So t1 is 3 seconds. And then m is increased by, so in the beginning it has m, and later it becomes what? M plus 1, and here they have also given that, so t2 equals to what? So t2 equals to 5 seconds. As a result, so what we have to find out? So we have to find the m here. So finally, so to find this, So we know the relation for the time period. What is that? 2 pi root of m divided by the k. So therefore, so t square is directly proportional to the m. So if that is the case, t square means what? So that is I can take it as first I'll write t square is directly proportional to the m. So therefore, so that is t1. I just write it as t1 divided by t2 whole square, that is equals to m divided by m plus 1. So what is t1 by t2? That is 3 by 5. 3 by 5 whole square means it is 9 divided by 25. Okay, when I simplify this, what do you get? So that is 25 m. Okay, 25 m equals to 9 m plus 9. Okay, when you simplify this, that will be 16 m equals to 9. Okay, m equals to 9 divided by the 16. Okay, 9 divided by 16, so that is the option 4 is the right answer. Okay, fine. So next, given below are the two statements. So one is assertion and the reason. So look at the assertion here. If a current flows through a wire of non-uniform cross section, potential difference per unit length of the wire is same throughout the length of the wire. So what they have given, it is a non-uniform. So we know that in any conductor, so what is going to be the constant? So current is going to be the constant. Okay, whenever it is a non-uniform, something like this, if the area of cross section is greater here, it is less, and again it increases. If the area of cross section changes, what actually changes? Okay, that is the resistance changes, because so we know that R equals to what? So R equals to rho L divided by the A. So we are looking for the potential difference per unit length. So that means length will be the same. The length is the same, but actually area is not the same. If the area is not the same, resistance changes, and as a result, voltage difference. So that also the changes, but not the current. So therefore, so first statement becomes a wrong statement. So current remains the same. R changes, as a result, V also changes. So therefore, first one is wrong. Next one. Reason is what? Current through the wire is the same at all cross section. So that is actually the correct statement. So therefore, A is the false. R is the true. So that will be the right answer in this particular case. Fine. The force per unit length between the two long parallel wires A and B is 0.004 Newton per meter. The conductors are 0.01 meter apart. If the current in the conductor is A, that is twice that of the conductor B. That is twice that of the conductor B. What they have given, IA equals to twice the IB. Then the current in the conductor B, that is IB equals to what? Fine. So now we will just substitute. What is the equation for a force per unit length? That is given by a small letter f. That is mu naught. IA IB divided by 2 pi r. So we know the force. We also know the mu naught. We also know the R. We have to just find the B. IB we have to find out. So therefore, I just substitute the IA. And if you substitute the IA, so what do you get here? Mu naught by 2 pi. I'll just write it as 2 into 10 power minus 7. So that is 2 into 2 into IB square. Divided by just the R. R value is how much? R value is 10 power minus 2. Force value is how much? That is 4 into 10 power minus 3. So this 2 into 2 will be 4, 4 will get cancelled. So 10 power minus 7 divided by 10 power minus, so that will be 10 power minus 5. So that is IB equals to 10 power minus 3 divided by 10 power minus 5, therefore it is 10 power plus 2. If it is 10 power plus 2, so what will be the IB? So here actually we have the square. So IB square is 10 power 2, so therefore IB will be just the 10 ampere. That is the option 3 is the right answer. Correct. Fine. So next, a parallel plate air capacitor has a capacitance C. When it is half filled with the dielectric constant, that is the pi. That is as shown in the diagram. Then the percentage increase in the capacitance will be. So here what they have done is, so this lower part of is filled with the dielectric constant K, and here it is the air. So this particular one, it is as same as something like this. This particular one is half of this particular one is filled with the dielectric K, and here it is just the air medium. So what is the meaning here? Whenever we have a plate, so that particular something like this, we have a plate and that is divided into the two parts. So that means area becomes what? So area is reduces to half. If area reduces to half, So then what we can say, so what is the effective capacitance for these two? So these two are in a parallel combination. Okay, C effective will be what? So okay, that is epsilon naught A divided by 2D, because area becomes what? A by 2. So we can this one, okay, plus, so we have a K epsilon naught A divided by 2D. Okay, so therefore what we can write, epsilon naught A by D is the previous one, C. So therefore it is a C by 2 plus K times the C by 2. So that is the effective capacitance. So what is the value of the K here? So value of the K is 5, 5 plus 1 divided by 2. 5 plus 1 is 6, 6 by 2 is, okay, 3. So therefore effective is, okay, thrice the C. If the effective is thrice the C, what is the increment? So increment, change, okay, change in the capacitance, that we can take it as 2. So that means, so whenever you multiply it by 100, so that becomes what? That becomes a 200% increment. So therefore that is option 4 is the right answer. Next, the image formed by a convex mirror of focal length, that is given by 30 centimeter, is a quarter of the size of the object. So what's the meaning? Image size is 1/4 of the size of the object. So that is m equals to, okay, 1 by 4. Okay, then the distance of the object from the mirror is, so that is distance of the object is as u, we have to find out. We have a relation between m and the u, so we can write that f, okay, m equals to f divided by f minus u. Okay, m we know that it is 1 by 4. Okay, what is the value of the f? F is 30, so that the 30 divided by 30 minus the u. So cross multiplied, okay, this. So that is 30 minus u equals to 120. So u equals to minus 90, okay, centimeter. So that is, okay, so therefore 90 we can take it as the magnitude. Fine. So in a LCR series AC circuit at resonance, so at resonance, that is XC equals to XL. So that is capacitive reactance equals to the inductive reactance. So it's a very simple one, right? The next, the electric flux entering and leaving an enclosed surface. So now let us say we have a closed one. So entering is phi1, leaving is, okay, phi2. Then electric charge inside the surface. So what is that equation we have? Gauss law. Total flux is directly proportional to the charge enclosed. So when it becomes positive here, whenever it leaves, it is a positive. Whenever it enters, it becomes a negative. In that particular case, total flux will be what? So total flux will be, okay, phi2 minus the phi1. So that is Q divided by the epsilon. So Q equals to what? Phi2 minus phi1. So multiplied by the epsilon. That is the option 2 is the right answer in this particular one. Okay, a conducting rod of AC, okay, of length 4L. Okay, rotated about a point, that is the O. Okay, in a uniform magnetic field B directed into the paper. Okay, if AO equals to L and CO equals to 3L. Okay, so then what happens? So here we have a point, this is the O, A, okay, C, and it is under a, okay, rotation about this particular point, okay, something like this actually. Okay, the representation there is not clear. So if that is the case, if this length is L, and if this particular length is 3L, so okay, which particular one is the right answer here? So you have to remember this particular one. Whenever it is undergoing to rotate, okay, so the charges inside the conductor experiences the force, and as a result, so at the edge, okay, we observe that, so there is a negative charge, and at the, okay, center, so that becomes actually the positive charge. Okay, so therefore, so if that is the case, what happens here? So look at, if you look at the potential difference, whenever you are looking for a potential difference, so that is VA minus, let us say VA minus VO. VA will be negative, so VO will be positive. So minus, okay, V, okay, minus here, and it is plus here. Whenever you take the difference, okay, that value will be, again it is a negative value. So here the okay, magnitude wise it is correct. So but actually they have given VA minus the V naught is B omega L square by 2. So but actually it is minus of that. And if they have given something like V naught minus VA is B omega L square by 2, that is correct. So therefore, if you look at the, okay, all the options, so here the general equation for the, okay, EMF induced is half, okay, B omega L square. That is the general equation, and here the length is L, okay, therefore it will be L square, and with respect to this length will be what? Okay, length is 3L, okay, when you square this it becomes 9L square. Okay, so that means at this particular point we will be having 9 by 2 B omega L square. Okay, VA will be okay, that is 1 by 2 b omega L square. What is the difference between them? Both will be negative. So this is also negative, this will be also negative. When you take the difference, that is VA minus a VC. So minus of minus becomes a plus here, and this will be negative. VC is greater than actually the VA, so therefore we will get the plus positive quantity here. So that is 9 by 2 minus 1 by 2. So 9 by 2 minus 1 by 2 will be what? Okay, that will be 4. So therefore option 3 will be the right answer here. Okay, so you can just do this particular one. So let us say if VA minus VC, okay, that is 1 by 2 b omega L square, okay, minus plus 9 by 2 b omega L square, and when you simplify this, okay, you will get it as the 4. Okay, fine. A light with the average flux, okay, flux is given, okay, 20 watt per centimeter square, that is acting on what? Non-reflecting surface, okay, at a normal incidence. So then, okay, the total area is what? 20 centimeter square. Energy received by the surface during the span of 1 second. Okay, fine. So we'll write this flux. Flux is what? It's the intensity. How do you write it? Energy per unit area per unit time. So therefore, what is the total energy absorbed? Okay, that is I into A into T. So I is what? It is a 20 watt per centimeter square. Okay, remember this. Okay, here also we have the centimeter square. When you multiply that, so that will get cancelled. So we can write as multiplied by area, that is just the 20. So here we are saying watt. It implies that for 1 second. So therefore the time here whatever given, that is a 1 minute. So for 1 minute we have a 60 seconds. So if you just multiply this, you will get the answer. 2 into 2 into 6. So that is 4 into 6, that is 24. 24 into 10 power 3, okay, joules. Okay, that is, okay, option 2 will be the right answer here. Correct. Next, a frictionless track ABCDE ends in a circular loop of radius r. Okay, a body slides down the track, okay, from a point A which is at a height h equals to 5 centimeter. The maximum value of the r for a body to complete the loop successfully. So what's the meaning here? So whenever a body is released from a certain height, so look at this way. So if a body is released from this and it has a certain height h, and here it has a radius r. Okay, this particular height will be what? This particular height will be 2r. Whenever a body is released from a certain height h, it has a potential energy given by what? mgh. Okay, and whenever whenever the body comes to this particular position, okay, it will be under this motion. At this particular point, what should have? So it should have a velocity that is given by root of the gr. Only whenever it has a velocity root of the gr, it completes that particular vertical circular motion. So that means whatever the total energy at this particular point here, when the block reaches this particular point, it has a kinetic energy and also it has the potential energy. So therefore, so by using the law of conservation of energy, we can write that. So that is initial energy equals to the final energy. So it is mgh equals to, so what we can write? So that is kinetic energy is half m v square, that is a gr, okay, plus mgh, again mg, what is the height in this particular case? That is a 2r. So therefore it is the 2r. Okay, if that is the case, when you simplify, mg is a common term, okay, we can cancel that. So h equals to what? r by 2 plus 2r. So that is the 5 by 2r. So therefore, what is the maximum r we can have? So that is the 2 by 5 times the h. Okay, so what is the value of the h here? So h is the 5 centimeter. So when you multiply this, so if I write it as 5 centimeter here, 5 will get cancelled. So this becomes the 2 centimeter. Okay, that is option 1 is the right answer. Okay, so we completed this all the 45 questions of the 10th mock paper. Okay, thank you for this particular watching. And also if you liked our videos, please share and also subscribe and hit the bell icon. Thank you.